All right, this question, we are doing some electrolysis of water. I have the balanced chemical equation going on. The opposite, hydrogen plus oxygen forming water, would be spontaneous. We see that if we mix those with a spark, we'll get that violent eruption of water forming. But here we're going the opposite. So we need some sort of power source, which is why it's electrolysis. So we're putting power in to separate water into hydrogen and oxygen. Now, with electrolysis, we got a couple options. Here we have, we're given the liters of hydrogen produced at a certain temperature and pressure, which then we'll need to get to moles from here. And then we need to get into moles of electrons. So we need our balanced half reaction. That can then get us into charge, which is coulombs. And if we wanted to go one step forward and figure out our amperage coulombs per second, but in this case, we are going to stop here. So you could be given mass, which you convert to moles with molar mass from the periodic table. Here we're given a volume. And so we're going to have to do PV equals nRT. Before we do that, let's look at the half reaction. So we're going to break it into two. One is the hydrogen. So we go like that. The other one, which we're not going to worry about too much, is this. We got hydrogen, oxygen, right? It's a -2 here, and it's a 0, so it's being oxidized. This is a +1, 0, so hydrogen being reduced. So let's take this half reaction here, and we're going to assume acidic. So we got to add a water to this side to balance it. Now we got 4 to balance oxygen, so we got to add H+, 2 of them on this side. So these would cross out. So we got 2 H pluses going to H2, but we need to balance the charge as well. Since the H pluses are on this side, we need 2 electrons. So we see here, there are 2 moles of electrons for every 1 mole of hydrogen gas. So that's going to be important in this process over here, right? That conversion. So first thing we got to do is get to moles of hydrogen here now that we have our balanced half reaction. So I'm going to do that by I got PV equals nRT. I need to solve for N. So I'm going to say N equals PV over RT. Pressure is given to me at 1 atmosphere. Volume 1.75 liters. R, we're in atmosphere, so we're going to and then Kelvin, we got 273 plus 25 Kelvin. So we see liters canceled, atmospheres canceled, Kelvin canceled, and we're left with moles. So our N, when we multiply 1 times 1.75 and divide by everything on the bottom, 298 times 0.0821, we get 0.07154 moles of H2. So now we're at this step here. Now we got to multiply for every 1 mole of H2. There are 2 moles of electrons. For every 1 mole of electrons, there's 96,500 coulombs. That's this number up here, right? So that number is not saying coulombs per mole of stuff. It's per mole of electrons. And so that's where we're using this number. So we're going to then multiply through our 0.07154 times 2 times 96,500. We get a big number here, 1.381 times 10 to the 4th. This is in coulombs. And again, if we had been given a time, like how many seconds, we could divide that by seconds and get our amperage, which is what we're used to seeing in electricity, is that amperage. So let's clear this out. Put that in. I'm going to go 3 sig figs. And there is our answer. Yes, so not spontaneous. So this electrolysis, we got to put energy into it, electricity into it, solve for moles of stuff moles of electrons multiplied by Faraday's constant 96,500 per mole of electron. And then we could go to amperage if we want, but don't need to in this case. There we go.